G'day folks, it's DIY Guy 123 here, bringing you another do-it-yourself video. I was putting together a video that you'll find on my channel about a probe tester, and it occurred to me that in order to use it properly, you need to know a bit about basic automotive circuit theory. Okay, so this is a basic circuit diagram you'd see in an automotive application, but it applies to many other types of applications as well. So we have a 12-volt battery with a connection to common on the vehicle. Some people call it ground. And then we leave the positive terminal of the battery and we head to a 10 amp fuse, and it leaves the fuse and comes along and goes to a switch, which is open at the moment, and the current will come along and go through a coil. And this is a relay. I'm going to talk about this in a minute. And then the current path will come down, back, and flow through to common. So when you close that switch, you'll drive current through this coil. When this coil has current flowing through it, it generates an electromagnetic field, which closes this switch that's all built into the relay. And when that switch closes, it introduces this path from the battery through the fuse up through this wire, through this switch that was closed, through a light bulb, and back down to common. Now, some of you that are really knowledgeable about automotive circuits would know that this switch typically isn't connected to the same 10 amp fuse. There'd be another fuse that handles a bunch of switches. But for argument's sake, I think this is probably helpful to draw it simple like this. So when this switch is closed by your finger, it causes this switch to be closed by electricity. Now in this case, the light bulb that we're going to use draws about 5 amps. So the current capacity of this switch is much higher than this one. So now that we know the operation of the circuit, we need to learn how to apply the new tool that I'm going to show you. Well, you can take the voltage probe and check right here and prove that there's 12 volts here and here and here. If you take the voltage probe and you probe on this side of the fuse and you get 12 volts, but you probe on this side and you don't get 12 volts, that means that your fuse is bad. So oftentimes you can take the fuse out and take a look at it, but what if you don't even know where the fuse is? You can't find the fuse. You could probe on this side of the switch. And if you don't get 12 volts here, you'll know that either the fuse or the wiring to the fuse is bad. Or if you get 12 volts at the fuse and you probe at the switch and you don't get 12 volts, you know that it's wiring between the two. So you're going to use this probe to probe various areas on the circuit and verify that you do or don't get 12 volts. And if we look at when it's not activated, you should have 12 volts all the way along here, but not there because the switch isn't closed, and all the way up here, but not there because the switch isn't closed. So that's how you can verify all of this with the probe. But on the other side, what if you had a bad connection to the negative terminal of the battery, a bad ground? Well, you can find out if you have 0 volts right here at the negative terminal of the battery, at the wiring, if you have any points you can tap into it, at any junctures, and all the way up to the relay, you need to see a ground. Now, when that switch is not activated, you would see 0 volts all the way over to here. So use your voltage probe in those spots to verify that you have continuity all along here. And all the way up to the light bulb, and on the opposite side of the light bulb, and all the way up to the relay. If this is not energized, you should see 0 volts all the way up to here. So that's how you can verify the wiring in both directions of the circuit. Now let's activate. We take our finger and we push down on the switch. So basically it shorts these two wires out. We should now see 12 volts at this location and 0 volts there. So you can probe those two spots when the switch is closed. Likewise, when this switch is closed, this energizes and closes this switch, you should see 12 volts here and 0 volts there. And so if you do all of that, you've verified that the relay is functioning. But what if the relay is not functioning or there's something else going on? You can pull the relay out. And this is a nice feature of the probe. Not all probes have this, but you can apply 12 volts here and the light should come on. Or what if this switch is faulty? You can apply 12 volts here, which will cause the whole relay to come on.